Hello, I'm Martin Beebe, Principal Developer Advocate at AWS, and today I'm going to be talking about building your own infrastructure in .NET with the AWS Cloud Development Kit. You might have heard of it being called CDK. That's commonly the way that people refer to it, the CDK. And it's a way of using code to define your infrastructure in AWS. So whatever you can build through the console or CLI in AWS, you can now build using this new thing called a CDK, which allows you to use your programming language of choice to define, all the different infrastructure and use all the different services that AWS have to offer. So we're going to be talking a little bit about what is infrastructure as code. It's a phrase that we'll use a lot, infrastructure as code, and explain what we mean by that and how that's going to affect what you're using the CDK for. And then we're going to be looking at, well, what is the AWS CDK? What does that bring to the table? What's new about that? And we're only going to be spending a few minutes on these things. And then finally, we're going to go through a number of different demos, which should hopefully give you some sort of insight into how the CDK works. So if you've used CloudFormation before, you might recognize this sort of JSON script. So the way that CloudFormation works is that you either write in YAML or JSON and you create your infrastructure. You describe your infrastructure with JSON or YAML, and this is describing an Elastic Beanstalk application. And then once you have your script, you basically send that over to the CloudFormation service. You upload it using the CLI, for example. You take your file and you upload it to CloudFormation service, and then the CloudFormation service reads that template, that file, and then it goes and starts creating infrastructure based upon what you've described in that file. Now, CloudFormation is very, very good. It's really useful. Lots and lots of people are using it. Lots of our customers are using it. But the problem with it, I guess, for some people like me, especially developers, is that I don't really want to be working in YAML or JSON particularly. Some of these CloudFormation templates can get very, very large. And for me, I think I want to use the power of a programming language to define my infrastructure. And really that's what the CDK is allowing us to do. So sometimes you might be talked about infrastructure in code. We're talking about infrastructure as or is code, so infrastructure is code with the AWS CDK. So you're using code to define your infrastructure, and you can use a number of different languages. Today we're going to be talking about C# using .NET, but you can use a number of different languages from TypeScript, JavaScript, Java, and Python as well. And there'll be more potentially languages coming in the future as well. And if you do have specific languages that you want to support, which we don't currently support, then do let us know. We have all of the CDK is hosted on GitHub, and you can raise issues there and tell us what you want us to support next. So the AWS Cloud Development Kit is multi-language in that you can use TypeScript, JavaScript, Java, C# or Python, as I mentioned before. And in its base, the base language is TypeScript. So if you ever look into the base implementation, you'll notice that it's all written in TypeScript, and that's like kind of the primary language, I guess. But then we have a number of languages which we've built on top of the TypeScript infrastructure so that we can support other languages. Now, when you're using the CDK, for a very short period of time, you're going to be having to use some Node or some JavaScript just to download it and to get it running. But once that's happened, then you're going to be working in the language of your choice. So you can start working in C# in this instance. Now, I'm a C# developer by trade. I do speak a number of these other different languages, but it's quite cool that I can define this stuff in C#, and C# has the exact same coverage as all the other languages as well. So there's no benefit really to going to over Java, over C#, over JavaScript, over Python in this CDK. It's really what language you prefer to work in. What language are you most performant in? Which language are you most productive in? Choose that language and then start defining your infrastructure. So on this slide, you can see a very simple CDK example. And if you actually use the sample, the sample application template, so I'll be showing you some commands. One of them is init, and init will create your application. Now, if you pass instead of init app, if you pass over init sample app, then it will actually define this piece of code that we're looking at right now. And it's basically an example application for you to see how you could fit together something in the CDK. So all it's doing is it's defining a couple of pieces of infrastructure. It's defining a queue, and it's creating an SNS topic. And then it's taking that queue topic and subscribing to a queue. So it's basically creating two pieces of infrastructure, and then it's coupling them together. Now, this is a few lines of code, but actually the CloudFormation to write something like this would be much more verbose. You'd have to write a lot more code than we have here in this example to get that same piece of infrastructure. And this is a very, very simple example. And you'll find as we go through the demos today, the more that you start doing with the CDK, the more time you're saving, the less code that you're having to write. So you'll note a few different things about this. We're importing libraries at the top. These are NuGet packages. AWS, oh sorry, I've just noticed that this is actually I've just noticed that that's actually the TypeScript thing. What you'll notice there is actually they're importing 3 libraries. They are not NuGet packages at all. They are JavaScript packages, Node packages. In the C# versions, you'll see the same sort of thing, but instead of 3 imports of Node libraries, you would be importing 3 NuGet packages. And when we import those NuGet packages, those are what provide us with the building blocks to start building our application. So if I actually go over to an actual C# example, that's better. This is Hello World in the CDK. And it's the same piece of code as we just saw in a moment, but this one is actually C#. I actually got fooled there. TypeScript looks very, very similar to C# when you're just looking at it on a slide. And you'll note at the top, we're importing a number of different NuGet packages. So the Amazon.cdk, which is like the base NuGet package that we're going to need on line 1. Then we've got the SQS package, which is going to be used to import the SQ or create the SQS stuff for us. We've got the SNS package and the SNS subscriptions package. So we import those 4 libraries at the top of our file, and then we can start using those libraries. Now, the general rule is that a service in AWS has its own NuGet package in the CDK. So if you're wanting to use SQS, then you would import the SQS NuGet package. If you wanted to use S3, then you would import the S3 NuGet package. And so we have a whole library of these NuGet packages that you can use. And what those packages contain are a terminology you'll hear a lot is a construct. And these constructs are a way of defining your infrastructure. And you can see here that when we're defining the queue, we're creating a new queue. Now it looks very much just creating a class. This is really a construct that we're creating. Now it's one which is baked into one of the libraries that we provide. But I think the real cool thing about the CDK is that if you want, you can start to define your infrastructure in a way that you like it to be defined. Maybe you want to create a VPC, which then has some EC2 images contained into that VPC, and you want to do it in a specific way. You can create the code to define that piece of infrastructure, and then you can wrap it up in your own construct, and then you can share that construct with other people in your team, like as a NuGet package effectively, so that they can also create infrastructure in the same way as you have done previously. And you can start standardizing around how you create infrastructure. And so we provide a number of constructs, but there's opportunity that you could create your own custom constructs for your company, or maybe even you might think, do you know what, there's a really common pattern that people use. They always use, maybe they're always using queues and topics together. And you say, actually, rather than having to import this number of NuGet packages, I'll create one package which does all of this, and then I'll distribute it as open source to the community. So we're expecting lots of people to be creating these constructs that you can build different pieces of infrastructure. And these constructs can be higher level, so they can do lots and lots of different things, and you can customize them in many different ways. There's a few pieces of terminology that you should be aware of when we're talking about the CDK. We call a CDK application when we initialize a CDK application using the command line, we're going to create sort of a skeleton application. That application in this instance is going to be a C# application. It's going to have a void main. Inside that void main is going to be basically a piece of code which creates a stack. Now, an application can have one or more stacks. If you've used CloudFormation before, you'll probably be aware of this concept of stacks. If you create a set of infrastructure in CloudFormation, they call it a stack. Well, this is the same sort of concept. Your CDK application probably will, in most of these demos, I think all of these demos, we just have one stack, but you could have many stacks, and it's going to match one-to-one. When we deploy it, it will appear in the CloudFormation console as a stack or multiple stacks, depending on how many stacks you add to your application. So we create a stack which contains a number of these constructs. So in the previous example, we had the queue construct and we had the subscription. Those are constructs we've joined together and they're part of our stack. So when we deploy our application, it will deploy all of the stacks. And when it deploys a stack, it will deploy all of the constructs that have been defined inside of that stack. So we have a single application. It can have one or more stacks, and it's going to have one or more constructs in each of those stacks. Now, it's important to know that the CDK isn't magic. It's not doing things completely differently from how we currently do CloudFormation. It's really more of a productivity gain, and it's also changing the way that we interact with CloudFormation. But make no mistake, it is still using CloudFormation in the back end. What actually happens is when you create your application and you define your stacks and you define the constructs inside of your application, you then have an application that you will deploy. And when you deploy it, or when you synthesize it, which is another command that you can run, what it does, it takes your application and it compiles it into a CloudFormation template. So on your machine or on your build server, it will take the CDK application, it will compile the application, and it will output a CloudFormation template. Now that CloudFormation template is a plain old CloudFormation template. It is not doing anything specifically for the CDK. You could take that code and you could go to the CloudFormation console and you could literally deploy that CloudFormation console template as it is. Of course, generally speaking, we actually will deploy it for you using the command line, but it's important to know that your application gets sort of compiled into a CloudFormation template. We're not doing any direct interactions with the cloud or the AWS cloud in any other way. What we're doing is the CDK generates a CloudFormation template, which is then deployed, which has a number of benefits. One is that we still look to the CloudFormation template, the CloudFormation console for our stacks. So if we deploy a stack, an application which has one stack in it, then we will go to CloudFormation console and you'll find a stack there which basically has all of the infrastructure that you defined there. It's still AWS CloudFormation, which then takes that CloudFormation template, processes it, and deploys all of the infrastructure. So we've not created anything new to do the actual deployment. All we've done is created this new sort of interface so that you don't have to write just YAML or JSON. You can now start writing your infrastructure in C# or all of the different languages that we support. When you're building your applications, you're going to be using the core framework to create an application, stacks and constructs. But then when you're wanting to pull in different constructs, we have a thing called the AWS Construct Library, and this contains constructs for many different types of AWS services. So if you want to build AWS Lambda applications, or maybe you want to create an API gateway, then there'll be a construct inside of that AWS Construct Library. Now, I will mention that the construct library isn't 100% complete in terms of covering all of our services. We're getting there, and we're obviously, as we release new services, we're trying to make sure that they have constructs released for them in the CDK. And of course, there's nothing really that you can do because it all ultimately goes down to CloudFormation, CloudFormation itself doesn't cover 100% of the services. So it's important to remember that there are limitations as to all of this. You might hit a place where you find actually this particular service, I can't define it in the CDK because it's not supported as a construct. If you find yourself, you can do, one, if it is supported by CloudFormation, you could write your own construct to start using that service. And that's completely possible. And lots of our customers are already doing that to sort of fill the gaps where we haven't actually released official constructs. So there are ways around the fact that we might not have 100% coverage. Obviously, it's all open source. If there are specific constructs that you want and you think we should provide, then please do let us know on GitHub. The other final piece to building an application is you're going to be using the CDK CLI. I've mentioned it already. It's only got a few different commands in the CDK CLI. It's important to know that it's written, I believe it's written in Node. Yeah, it must be because it's delivered as a Node package. You can do CDK diff and CDK synth will be the most common ones. There's also a CDK init, which is the creation of an application as well. CDK deploy obviously takes your application, compiles it, and then deploys it. And what we mean by deploy is it takes the CloudFormation template from your machine and it sends it over to the CloudFormation service in AWS. CDK diff is another command which will diff the difference between what you have built on your local machine and what's currently deployed. So this comes into play when you've already deployed and then you make some changes and you want to see what the difference is between the two stacks. You can do a diff and it will do a comparison. And a CDK synth is basically build the CloudFormation template for me, but don't deploy it yet. And this might be that you want to verify what's in the CloudFormation template, or maybe you're just curious as to how they're actually defining or building some of this stuff in the CloudFormation template. So you can synthesize it and it will generate the template for you. It will actually emit the template directly to the terminal or the command line that you're using, but it also generates a little folder that you can go into and you can look at the files which it generates as well. So to install the CDK, we need to have Node on our machine because it's delivered as a Node package. So npm install globally AWS-CDK. That will go and get a number of different Node dependencies. And once you have that, that's pretty much the install. It doesn't take very long to install it. Obviously, I have Node on my machine already, so there's some benefit to that as well. But it's quite a small package initially. And that's the thing which we talked about before is this concept of constructs. The core CDK is basic, but then when you start using different services, you'll need to import new constructs. But those constructs are in their own module. And so it means that the base library is actually quite small, and then the subsequent constructs, they get larger potentially, depending on how many you use. But that's a benefit because most people are probably going to be only using a handful of different constructs. So it's possibly the best way of doing it rather than downloading the, I don't know, hundreds of constructs that are available as a single package. So once we've got the CDK down, we can then start building in the language of choice. Now, it's fair to mention that you will need, if you're building .NET applications, you're going to be needing .NET Core on your machine. This is how it works, how we use a number of .NET Core tools to build our applications and deploy so that we can deploy them. So you're going to need .NET Core on your local machine, and you're going to need some kind of editor. I'm going to be using Visual Studio VS Code, but you could use Visual Studio 2019 or any editor really, or Rider by JetBrains. It doesn't really matter too much. We have to issue a number of commands in the command line. So you'll note that we do need, if we're going to be building and deploying C# applications, we're going to need .NET Core on our local machine as well. So Node, .NET Core, we're going to have to install the npm package locally on our machine. Then we can start building our application. So I'm going to create a very simple hello world application. And what we're going to do is take advantage of the ability to to use assets which are local on my machine, and we're going to deploy some of those local assets with our CDK deployment. So I'm going to try and create a very straightforward website, and I'm just going to be using S3. So I don't know if you know, but S3, the storage service at AWS, also have this sort of on-the-side capability of hosting websites. So you can host static websites effectively. So if you put an index.html in a bucket and you set up the bucket in a specific way, then you can actually use that to host a static website. I don't recommend that you do it this way particularly. If you are interested in this, there's a great service we have called Amplify, Amplify Console, which allows to do static website deployments. But this is showing you how you could create that sort of website directly using the CDK. So I'm going to go to my terminal and make a directory. Hello world. I'm going to go into that directory, hello world, and I'm going to do CDK, which is using the npm package that we've just installed. Init app. App is actually a template, so I could use sample app there and create a sample application template, and then just choose the language as C#. I'm just going to give the project a name, hello world. Press go on that, and it's going to then create a sort of skeleton application for me. So if I list that, you'll see that there's a README file, a cdk.json, and a source folder. I'm going to open that up in Visual Studio by typing code dot, which will open that up in my application. And it's asking me to just install some NuGet packages and something else. Close that down. And if I go into the source folder, you'll find that there's a hello world folder with a C project, a C# project. We have this thing called our hello world stack.cs, and we have our project file. I'm going to use a number of different NuGet packages in here, so I'm just going to add them here. So I've got the CDK package installed. I'm also going to add the S3 package. I want to do a deployment. And so there's a construct library for that called S3 deployment. And I am actually included in CDK, so I don't need that one. So that's the three NuGet packages I need to install. If I save that, it's going to ask me to do a NuGet restore. I'll do that. So that's just a .NET restore in the folder, which is done there. And I'll go back to my hello world stack. And at the top, I'm going to start defining my infrastructure. Now I'm going to need to import the actual files, aren't I? So using amazon.cdk.aw3, it's .aws.s3. That's right. And I'm going to create a bucket. I'm going to create a new bucket. That's a class in that S3 library. I'm going to pass in this, which is the scope of the CDK application. This is a pattern that you'll see repeated. I'm going to give it a name, bucket, and I'm going to give some bucket properties or bucket props. So I'm going to pass in this new object called bucket props, and this kind of defines some properties on that bucket. This is kind of common pattern. This in the scope, and then some properties for the object. So with this bucket, S3 bucket, I'm going to give it a name. The bucket name's got to be globally unique, so I'm just going to prefix it with the Beebs CDK demo B. I know that's probably going to be globally unique. The Beebs, by the way, is my Twitter handle, if you don't know. And I'm going to give them access control. I'm just going to make this bucket access public read, so it's publicly readable. And I'm going to say the website index document is index.html. So you could define this as index.htm or default.html or whatever you want to define it as. But this is, I'm going to say, look for the index.html, and that would be the root file for any websites that are hosted in this S3 bucket. Now I need to add some permissions to this particular bucket so that people can actually access it, because they'll need that policy. There'll need to be some IAM policy, security policy set up so that people can actually read what the files are in the bucket. So I'm going to create a new policy statement. It's going to be quite, what's the word, forgiving. And it's going to allow basically people to read whatever's in that bucket. So I'm going to need, I've not got the policy statement resolving, so I think I actually need to install or reference, sorry, the IAM. Okay. Yeah, so it's policy statement. Yes, there it is, 5th down. Policy statement. And I create a new one of those. Pass in some policy statement props. This is an IAM policy. If you're not familiar with IAM, just don't worry about this too much at the moment, but just to let you know, this is providing the security context for this particular bucket, or it's going to in a moment. And the actions as, no, that's it. S3 get objects. Get object. And then I'm just going to copy that because it's easier than typing out new again. Define what resources that this principal is able to get. I can reference the bucket object, which is up there at the top, and they've got this sort of helper object saying ARN for objects. So all the objects in that bucket, I can define, I can say it can access all of the objects in that bucket, and I can say by providing a star using a wildcard there like that. So the resources that this is applied to is all of the objects inside of that bucket, basically. Principal. Any principal. There we go. So that's an IAM policy. Oh, got to put a semicolon there. That's an IAM policy statement. And now I'm going to attach that IAM policy statement to the bucket. So I'm going to say bucket add resource policy, and then provide it with that policy statement. Okay, so let's create a bucket deployment. So this is going to deploy, actually, why is that not resolving? It's not JavaScript for starters, so I'll need to change those into actual speech marks. Bucket deployment props isn't there. Oh, I guess that's because I haven't referenced it in my usings yet, have I? Ah, there we go. So I actually imported that in as a NuGet package, but I actually hadn't added the reference to the library, so S3 deployment. And now hopefully, yes, the squiggles have gone away. So I can say new bucket deployment props. And I'm going to assign the bucket. And the cool thing is I'm referencing these objects, the bucket object, just by the bucket name, by its object name. I'm not making a reference to an ID or anything like that. CloudFormation will need that, and it will generate all of that, but you're able to reference objects previously defined or pieces of infrastructure previously defined in there. So what I'm going to say is that my deployment is going to come from an asset locally and deployed to that particular bucket. So at the moment, there isn't this folder, but I'm going to create a folder called site contents, and that's going to contain my static website. There's a number of different ways you can do it. You don't have to have an asset which is local on your machine, of course, but this is a nice little feature. So that's going to deploy my bucket. The next thing I want to do is well, when this website goes live, or it's deployed, what's the URL going to be? Well, CloudFormation has this concept of outputs, and I'm going to output a variable effectively, so that I can see what the URL is. Now I could go and find the resources and find the load balancer and find the URL for this particular HTTP endpoint, but it's quite nice if I can say, well, I want to output some properties to the output of the CloudFormation. So I'm just going to output the bucket URL. This will, if you go to the CloudFormation console, there's an output tabs against any stack, and you'll be able to see this stored alongside the stack. But also when we use a deploy, when we go and deploy this thing, it's going to actually output it to the console as well, to our terminal. It's going to say what the bucket URL is, which means that once we do a CDK deploy of this, we're going to get a URL at the end of it that we can go to, and our website should then be there. Although we don't have a website at the moment, so we're going to have to create one. So at the root of this project, I'm just going to create a folder called site contents. And in site contents, I'm going to create an index.html. That is the name of the type of file, which I said was going to be the root. I don't even need to put HTML, but I will. And I'll just add h1 there and say, oh my goodness, it is live, exclamation. Some fancy HTML and JavaScript front-end work there. This could be any kind of static website, obviously, but I chose to use a very simple one. Go to our terminal now, and I want to deploy this application. So I can say CDK deploy. Well, if I do a synth first, actually, then synth will show us what the CloudFormation template looks like. And you'll see that it synthesized the CloudFormation template into our terminal, but also it's created this folder CDK out, and you can see there is a JSON representation of this CloudFormation template here. And that's basically the CloudFormation template, 337 lines of code that have been generated to create that infrastructure. So if you were just using CloudFormation, you would have had to have written all of that CloudFormation yourself by hand. So it's kind of a benefit, really. So we've just deployed it there. Because we've made some security changes, it's telling us, are you aware of these? And I said yes. And it's going out to deploy them. And then, boom, we have a website, which if I click and open, oh my goodness, it's live. We have the website live. So that's that. That's our website live and deployed using an S3 bucket to deploy a static website. If we changed our application and save that, and then in the terminal I'll just clear the terminal, and then typed CDK diff, I would see the difference between what I currently have and what's deployed. And so the difference obviously is that I've removed the output, the CloudFormation output. So I could maybe duplicate this, add a second bucket deployment. I don't know why, but I just wanted to show you that this, like adding stuff as well, if I do a diff, it will show that I've deleted that and added that other feature as well, that other bucket deployment. Obviously, this is C#, right? So as well, these constructs could be put inside of loops, or you could use if statements. It's a programming language, so you can do and create infrastructure based upon in lots of different interesting ways. Now using can use a programming language in ways that you can't really do. You can't use like if then, if this then that sort of statements inside of a CloudFormation template. So it's an interesting new way of creating these CloudFormation templates. And you'll see now the output of that CDK diff says that we've added that bucket deployment and we've removed the bucket URL as the output. And so if I were to deploy that, then that's the change that would be made to the live infrastructure as well. So that's creating a very simple website, hosting some static content. Let's look at something a slightly more complicated, custom resources. With CloudFormation, sometimes you have this situation where you have a bit of a chicken and egg situation where you're creating maybe two pieces of infrastructure, but one of the pieces of infrastructure needs to have a reference to the other piece of infrastructure. And so you need to make sure that one of the pieces is created and then you can reference back to it. The way that you solve this in CloudFormation is to create a thing called a custom resource where you can maybe create a Lambda function, and that Lambda function will wait for a piece of infrastructure to be created, and when it's then created it will then alert back, and so you can carry on with the rest of the deployment or a reference from that piece of infrastructure. Now the CDK makes some of that a little bit easier, and we'll be showing an example of that next. So do the same kind of dance. I'll make a little directory called custom. Please spell resources. I've got it written down here somewhere. There you go. C. That's it. CD into that file. And then CDK init. I'm going to just create a standard application again. So it's just going to be the boilerplate. I'm going to choose the language as C#. Of course, could be TypeScript, could be Python, could be Java. And give my application a name, custom runtime, custom resources. Creates my project for me, and then I can go into that project inside of VS Code. And at the moment, there's nothing in there really. We've got our stack. Just not now. Now I'm going to be using a couple of libraries to build this, so I guess I'll add them to the project. First up, so we've got the reference to the CDK already in there. We're going to need one to aws.s3 again. They all follow this format, by the way, amazon.cdk.aws. the service name. SQS, simple queue service, and S3 notifications. Save that, do a restore, and it will go and get the NuGet packages required for our project. And then hopefully I should be able to go back into the project here and just add those references to those NuGet packages up the top here. S3, AWS S3, I just explained that a moment ago and then got it wrong. Using amazon.cdk.aws.SQS. What was the other thing I needed? Notifications. Yeah, that's it. So in our stack, I'm going to create a bucket. This is just a really simple bucket. Doesn't need to be very fancy. We're just going to pass this as the scope, and we'll just give it an ID of bucket That's not the bucket name, by the way. That's just a reference. We don't need to add any properties to it, or do we? Okay, we'll give it a name. Beeves demo CDK bucket. I think that'll do. And then we'll add a queue. And we'll just pass the this context into it. We'll give the queue a name, an ID, sorry. And then bucket dot add event to notification. So when something's added to the bucket, I want to when the object is created inside that bucket, I want to send that over to the queue. So new SQS destination, the queue. Now it matters the order. The bucket needs to be created, the queue needs to be created, and there needs to be a reference back to them. So it's like a chicken and egg problem we have with this piece of code. And so what underneath the hood is going to happen is the CDK is recognizing this kind of race condition, and it's going to help us out by creating a custom resource for us. And it's actually going to be a Lambda function. But we just wrote and connected the two pieces of code. It's recognized there's going to be this sort of complication which requires a custom resource, and it will then create a custom resource for us. So if we look somewhere in the CloudFormation that it outputs, we should be able to find this custom resource. It's probably easier just to go to the formatted version rather than the one in the terminal. And then somewhere here, we should find here that it's deployed a Lambda function, and that's that basically is enabling that notification to take place. And so there's some stuff. Is that the? Yeah, there's these this ability that the CDK has is to recognize some of these sorts of complex problems and solve them. And so someone else has sort of had a headache about connecting up a queue and a bucket before and doing that and defining that inside of CloudFormation. And so they've defined this in this add event notifications construct. They've added this concept so that we can very easily create the infrastructure and the Lambda functions and various other things to enable this to just work. And so now we're going to have the abilities that when anything is added to the bucket, it's going to be passed over to the queue. When there's an event on the bucket, it's going to be sent over to our queue. It's going to be notified. Our queue is going to be notified or going to be added to. So that's an example of how the CDK is trying to simplify some of the the custom resource sort of requirements of CloudFormation. Now we showed a from asset example using S3 where I had a static website. But maybe we want to deploy something from, like we want to deploy a Docker container. Now, one of the very cool things that the CDK offers is the ability to use like a from asset that we did with S3, but doing that with a container that we have locally. So let's have a look at installing or creating a container locally as sort of basically creating a sample .NET application, containerizing it using Docker, and then having the CDK go deploy that. One thing to mention is I'm just going to walk through the code on this one rather than coding it out. It actually comes from a GitHub repository that we've got with a number of all the samples that we've seen today, and I'll give you the URL to this GitHub at the end of the presentation. It's built by a friend of mine and colleague, Steve, and Nikki Stone as well. And they've developed these samples that I'm showing you today for reInvent. And so the containers one basically contains a .NET application, which is a sample sort of basic React containerized application. And I think it's just the same one which comes out of the sort of the if you do file new project React application and you add Docker support, effectively you'll get, this will be what outputs. And so they've got that container application, and then they've added a number of some CDK goodness around it, CDK application around it, to then go deploy that local application to production. Now, if you think about what you'd have to do to deploy a Docker application, you have to build your Docker file, create a Docker container locally. You'd have to tag that Docker file, and then you'd have to upload it to a registry. That might be Docker Hub, or in AWS world, that might be the Elastic Container Registry. And once it's there, then you have to go and build Fargate. And then once you've built your Fargate service and constructed that, you'd have to point the Fargate service at the ECR registry to go and get the Docker container. And then it will create that, and then your load balancer, and then your application would be ready and your Docker files may be deployed. There's quite a lot of moving parts in that, especially the building the Docker image and deploying the Docker image. So there's been some work or a construct which has been developed which makes some of that a little bit easier, and that's what we're going to be using next. Now, we're going to need a few different bits and pieces. One of them is this construct library called amazon.cdk.aws.ecs.patterns. And this is an example of a library which isn't just for a service, but actually is built by the ECS team to provide a number of patterns which are really useful with ECS. And one of them is a load balanced Fargate service. And that's going to enable us to create this application much more simply than we would have been able to previously. So we got that NuGet package. We've added that NuGet, the reference at the top to amazon.cdk.aws ECS patterns. And then in our container stack, we're going to start creating our infrastructure. I'm going to create a virtual private cloud with one line of code there, not define anything about it. One of the things about the CDKs is what it should be is that when we're defining the constructs, we try and make sure that the defaults that they have are sensible. So with a VPC, we have used some of the best practice around how we would build virtual private clouds in AWS, and we've kind of built them into the construct. So you can define the VPC. There's loads of properties on that VPC construct that you can configure and change. But if you don't do any of that, if you just use a VPC, it will create you a basic VPC with sort of security best practices built into it. So that first line on line 14 there, var VPC equals new VPC, we're creating a virtual private cloud there, and then it's using all the defaults effectively from the construct. And then line 16, we create a new cluster. This is an ECS cluster, and we basically say the VPC is the VPC. We make a reference to the VPC which we made previously. Now, the next line on line 21, we create a definition, a Fargate task definition. If you've not used Fargate before, Fargate is our service for running containers serverlessly. So you don't have to define all of the infrastructure, like you don't have to create EC2 instances, for example. You can just give us your container effectively, and we will then run it on a pool of EC2 instances that we run and we manage. It's like a serverless containers service. So you give us your container, and then we run it on our infrastructure. So we create the cluster on line 16, and then down on line 21, we create our Fargate task definition. Then we're just doing a little bit of a C# dance to get the path to the .NET app folder. So the .NET app folder is where our containerized application lives. Now, this has got nothing to do with the CDK. This folder. This folder is basically a sample .NET application built in Visual Studio. What we're doing is on line 26, we're saying we're going to go and get a container definition based upon that application. And so we use this container image dot from asset, and we pass in the folder name. And what the CDK is going to do there is quite clever. It's going to look in that folder. It's going to try and find a Docker file. At that point, it's going to use that container. It's going to build the Docker file for us. It's going to tag the Docker file. It's going to push it to ECR. Now, you'll notice that in our code, we're not mentioning ECR, the Elastic Container Registry. We're not mentioning that. We're not defining it. We're not creating it. But under the hood, it's going to create ECR for us. It's a repository in ECR to store our containers. It's going to upload our container from our local machine. And then finally, it's going to actually deploy it from ECR to Fargate. We're going to say the port map. We're going to give a port mapping. So we're going to say our container port is on port 80 and the host port should be port 80 as well. And then in that task definition, we're going to add the container and we're going to add the port mapping to that container as well. Then we have to say the service properties. So we're basically saying what's the memory limit and the CPU limit of these tasks. So just finding them as 512 and CPU of 256. That's the requirements for this particular container. And then we pass in the task definition we've already defined. And then we create this application load balanced Fargate service. Now this is a construct which comes from that patterns library. And it's basically saying, create a load balancer, create a Fargate service, and here's the container and the description of how you should run that container. So in a couple of lines of code, we are deploying a containerized application there. Now the actual .NET app, if we look in that folder, it's just a C# .NET application. It's got a React front end. It's got a C# back end. And there's a Docker file there. You can see that we're doing a .NET Core build for SDK. It's a multi-stage Docker build. This is Docker stuff, not anything to do with the CDK. But this is that from asset that we used earlier on. It's actually going to be using this Docker image to actually go and Docker file to build the Docker image to then upload to ECR for us. So what that means is if we do a CDK deploy on the command line, it will go and deploy that file. It will take a little bit of time because, and this is why I've done it up ahead, because it will go and build our Docker image, as we've shown, from our local machine. It's going to build a Docker image. It will deploy that and push it over to ECR. It's then going to create all the Fargate infrastructure that's required, the load balancers and stuff, and then it's going to give us some outputs. Now these outputs actually come from that construct, that load balance construct. We didn't define these, you'll notice in there. So now if I copy that URL, paste it into my browser, boom, there's my actual containerized application. And if I click on stuff, it works. It's just a sample application. So that's my containerized application deployed using a number of different constructs, but making it very, very simple to sort of deploy a container. I didn't have to worry about anything really other than using a few lines of code, and boom, I've got my containerized service up and running. I'll finish in the next few minutes just showing you a more, I guess, real-world application, which is sort of slightly more complex. It's a serverless application, and it transcribes audio. Again, it can be found in the GitHub repository that we use for this session. And I'm just going to run through the code again to show you roughly what it does, and then we will deploy it. So this is the same sort of standard application as we've previously had. We've got this transcription stack file, and in this transcription file we have a number of different things that we've brought in. We've got IAM, Lambda event sources, S3, SNS, and SNS subscriptions. On line 16 and 17, we create an input bucket and an output bucket. The way that we want this application to work is that you upload audio files to the input bucket, and then we're going to be using an artificial intelligence service to recognize take the audio file and transcribe it, so basically convert it to text. And then it's going to take that text, put it into a JSON object, and then output that JSON object into the output bucket. So the basic idea is that you would upload a file to a bucket, and then at some time in the future you would have an output in another bucket. Now this is obviously asynchronous. We don't really know how long some of this would take, and so we need some way of calling back when the job's been done. So what we're going to be using is the simple notification service to send a notification back to us that the job has been completed. And this might be used in lots of different scenarios. If you were trying to transcribe videos, I had a company once use a very similar service to this where they wanted to transcribe testimony from their clients. They were a law firm, and they would record their clients, and then they would use a service very similar to this where they would upload the audio file, and then the system would transcribe it, and then they would have human editors then edit the files. So it just helped a little bit with the workflow of capturing audio. So this is the scenario that they're building. They're putting an audio file in an input bucket. It outputs the JSON. On line 19, we're just checking the language code, which we provide to the transcription service. So we're going to say, like, if it's UK, if it's an English audio transcription that's going to be doing, or maybe it's a Russian, or maybe it's a Chinese audio input. In this instance, if there's nothing provided, then we just provide US. Then I have you'll see, so that line 19 to 23 is just that language switch. And then line 25, we have this function. Now, what this is doing is going to create a function for us in AWS. Now, this is the function which is going to be connected up to the input bucket, and it's going to sort of start the job off. And so you'll note, I don't want to go too much into what it does, but basically it takes the code from asset again on our local machine. So we have two folders which contain functions, Lambda functions, and they're built in .NET, and it's going to go and get the code from the assets.startTranscriptionJob.zip folder. So we're going to have to do a bit of work just to take our Lambda functions, convert them to zip files, but once they're done, it's going to just take the code which it finds in the zip file, and it's going to upload that and create a Lambda function for us using that code. And it's also going to add an event to a bucket. So basically when an object's created in the S3 bucket, then it's going to kick off that particular function. So it's connecting those functions up a little bit. And we're going to add some security policies to it. We're going to add the role to the policy and grant access to the job so that it can read from the bucket as well. And we're doing that between lines 48 to 62. Then we're going to create on line 64 a notification. And this notification is going to be fired when the transcription job has been completed. And we're going to subscribe to that. We're going to subscribe an email address to that notification. And you can see there's an if statement saying if someone's passed in a subscriber email, then add that subscription to the notification service. When we create or when we deploy this, we're going to pass in a subscriber email. You can pass in properties to these CDK applications, and we'll show you how you do that. One of them is going to be subscriber email. So I'm going to pass in my email to this service when it's created, and then when any transcription job has completed, I'm going to get an email from it. And then we add another function, and this is a notify complete function. And this is basically going to be sent when any asset gets added to the output bucket. So once our application has outputted the job and outputs the JSON to the output bucket, it's going to fire another event, and that's going to send us a notification ultimately saying that the job has been complete. Okay, and again, I'm doing a little bit of there's a little bit of security stuff that we have to add to that. And then finally, we omit the input bucket name as a CloudFormation output parameter. So this is our functions folder, our functions folders. So if you look on the left, you've got a functions folder. It contains the notify transcription function and the start transcription function. These are just Lambda functions, nothing to do with CDK. and they do the work of either transcribing the audio file or making the notification that the transcription is complete. Now, inside the CDK folder, there's this cdk.json file, and you have a subscriber email, and you have I've defined how the application gets run, and so this is what explains to the CDK how you run the application. So, and this will be different for every language, but in .NET it runs .NET run and then passes over the project name. I've also defined the context, and there's two pieces of information: the subscriber email and the language code. And when I'm basically doing a CDK deploy, I can pass in the subscriber email and language code to the CDK deploy at deploy time, and it can change, the way that the CDK application is deployed. To make this easier, in the GitHub repo, you'll find a build and deploy PS, a PowerShell file. Now, this build and deploy file, what it's doing is it's creating our Lambda functions for us. So you'll notice on line 17 and 18, I'm actually doing the build of the Lambda functions. Now, it's outputting them to a zip file. And then on line 20, we're just issuing the CDK deploy command. And if I've added subscriber email or language code, it will also add it to CDK deploy. So we can go to PowerShell and we can run this script, build and deploy.ps1. I can pass in the subscriber email. I just leave the language one blank because it doesn't need it. It will just default to ENUS. And it'll say subscriber email martinbb@hotmail.com. That's going to then go off and build our Lambda functions. It's also going to build the infrastructure. And at the end, when it's done, it's going to say transcription stack.input bucket, and it's going to give us the name of the input bucket. So I can go over to S3. Oh, actually, I'll go to my email, and it will say you've got a notification that you've been subscribed to the transcription completed topic. I've been added to that. I have to confirm my subscription. And once I've done that, if I get that email, basically it means that the infrastructure is all set up and the SNS system is making sure that I want to be part or get subscribed to those confirmations. I confirm that subscription. I then go to S3 and I upload this piece of audio. Hello, my name is Martin Beebe, and this is recording to test if my transcription system is working. So it's just that this in the email, then it is. Sorry, I interrupted myself. It's just an audio file which has that little piece of transcription. Hello, my name is Martin Beebe and I'm tested, blah, 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 blah. So I upload that to S3. And then eventually I will get an email from AWS saying transcription complete. Transcription of audio file test MP3 is now available, and it gives me a URL where I can go to the transcription. So if I go to that URL and download it, this is the output that I get. And you'll see on line 7 there, it says, hello, my name is Martin Beebe. It's spelt that incorrect as if it's phonetically. It's actually spelled B-E-E-B-Y. And this is recording to test if my transcription system is working. If you get this in an email, then it is. So that's the transcription service. It also has loads of information about the confidence and various other things that is of it. But that's roughly what that is. So just to recap today, we showed you what infrastructure as code is with declarative templates like CloudFormation, what works and why maybe there's some benefit to thinking about it differently and using a programming language to define it. We've then introduced the CDK. I've shown you some concepts and tools and how you get started with the CDK. I've shown you the CDK bindings for .NET developers. I've shown you that it's a collection of .NET Standard NuGet packages. And then I've shown you a few different demos. All of those demos are available on GitHub. So https://github.com/steve@aws/reinvent2019-win310. If you're interested, the developer guide for the CDK, which gives you all the documentation, is available in all of the languages that the CDK supports. And then we have the CDK repository. It's where we build the CDK in open source on GitHub. So if you've got any issues, if there's things that you'd like us to add, then do add them as issues on the repository. And also maybe even help contribute. You could build your own constructs there, and you could resolve some of the issues that are on that GitHub repository as well. And we welcome contributions. And with that, I want to say thank you very much for joining this webinar. I've been Martin Beebe. I'm at the Beebs on Twitter. If you've got any questions, then please do ask away there. Thank you very much.